Hi guys, my name is Rizwan Tariq. Welcome back to another video. And in this video, we are going to be implementing our first Hello World program on Zynq Ultrascale Plus FPGAs. We will go through the whole process of creating Vivado Block design and we will learn it step by step. So let's have a look at what we have covered so far. So in the past videos, we have successfully set up our Zynq Ultrascale Plus MPSoC Ultra96 version 2 board, and we have prepared it for Linux. We have done some Linux testings, some web browser testing, and also we are able to SSH into our board. And then we also have installed Xilinx Vivado because to do some hardware and software development, we need Xilinx Vivado software. And we specifically set it up for Ultra96 version 2 board. And also in the last video, we have discussed some hardware and software co-design concepts. And this is actually really important video. If you are a beginner into hardware and software co-design, I will really recommend that you should definitely check out this video. This video talks about different hardware and software co-design concepts and also specifically related to Xilinx FPGAs, in which we have discussed PS-PL interfaces, what is PL and what is PL, and how can these two things can talk to each other on Xilinx FPGAs. We have also discussed hardware software co-design with the help of some example and how we can partition it and what are the hardware software co-design goals. So in this video, we are gonna be running our first Hello World application on the Zynq processing system. And as I said in the hardware software co-design concepts, that when we say Zynq processing system, that means we are running our application on the processor cores, and in this case on ARM cores. And I think Hello World in general is always a good idea because when you're running Hello World on your FPGA or microcontroller or any other specific platform, you get to know the whole workflow of that tool. You get to use that tool for the first time, and it's always like you always learn something new when you are running Hello World for the first time on a different platform. So in this case, we are gonna be running Hello World on PS, and we will get to know the workflow from Vivado Block design and Xilinx software development kit. So I think it's gonna be really interesting. So without wasting any time, let's jump directly into Vivado and start creating the project. So as you can see that we have opened the Vivado and click on the create project. Specify the project location and also specify the project name tutorial 1 hello world. Click next, select boards, and here we have to choose our board. And if you remember from the last videos that how we have added the AVNet board definition files, so you should be able to see all the AVNet boards here now. So here we are going to be selecting Ultra96 version 2 board and finish. So now Vivado is sort of initializing all the files specific to our board. So the first screen that you see is the project summary, and you can see all sorts of details here. The project name, the project location, your product family, which is Zynq Ultrascale Plus, and project part. This is basically your FPGA part number, and you can also see that we are using Ultra96 version 2 single board computer. So in order to run our Hello World bare metal application on the Zynq processing system, we first have to set up the Zynq processing system on Vivado Block design. And this, you can think of it also as like setting up the platform on which you're gonna be running your applications. So we click on the add IP button, and here we will see Zynq Ultrascale Plus MPSoC. So we select this IP. This whole IP is our Zynq processing system, and it has a lot of features. So what we are going to do right now, we will click on the run block automation and we will apply the board preset. So what this board preset will do, it will set up the processing system with some default options. For example, enabling the UART and also setting up your DDR memory. I will definitely recommend that you apply this preset because then you don't have to do all the complicated DDR settings. So let's double click on this IP and let's see what's inside it. So you can see that these are Zynq R5 cores, which are dual core. And here you can see that we have these Zynq A53 cores, which is quad core system. And here you can see all those interfaces which we have discussed in the Ultra96 block diagram. SPI, UART, CAN, I2C. And here is the PL, which is the FPGA. And you can see that there are a lot of interfaces which are in green. These different interfaces are used for different purposes. And here we have the DDR controller. Now let's go into I/O configuration. So we can see that we have low speed IOs and high speed IOs. In low speed we have so many different options, I2C, SPI, UART, and normal GPIOs. And you can see that we have these two UARTs, UART0 and UART1. And in high speed you can also see that we have this SATA and DisplayPort connections. These are generally in high speed areas. And in clock configuration we can see that this is the clock that is coming out of that pin which we have seen just before, and I will show you again when we come to that point. And this is the DDR configuration which I was talking about. So when you apply the preset, this DDR configuration will be set automatically for you. So you don't really have to fine tune this configuration anymore, and you can just use this memory right away. So in PSPL configuration, we can see that there are so many different things. As we also discussed in our last video, that there are different types of PSPL interfaces. We have interrupts, we have master and slave interfaces, and also you can see that when we applied the preset, two of the master interfaces has been enabled by that preset. And right now we don't have any slave interfaces enabled in the PS side of the system. And here are the interrupts, PS to PL and PL to PS. We discussed about these interrupts as well in our last video when we were discussing about hardware software co-design methods and how what is the purpose of these interrupts. We also discussed that before. So this was a quick overview of what is inside Zynq processing system. If you remember, when we applied preset, these two master AXI interfaces has been enabled. We are not really using them right now, so we can leave it as it is, but we have to connect the clocks of these master AXI interfaces, because if you don't do it, it will generate an error. So let me show you. If I try to validate this design, it will give me an error that I have not connected these two clocks. So this PL clock 0, this is my clock which is coming from the Zynq processing system, and I also showed you that where this clock was configured. You have to connect this clock to these two clock pins, and if you validate the design now, it will work just fine. So yeah, validation successful. So yeah, come to sources, click on create SDL wrapper, and it will create the top file for your Vivado block design. And you can see that we have this design underscore one underscore wrapper, and this is our top module. And in our top module we just have only one component, which is our Zynq processing system. We have not added any specific hardware component, which is FPGA logic, which is hardware. We have only added Zynq processing system, and Zynq processing system is our software cores, is our software ARM cores, right? So we don't have to do anything else right now. We don't have to add any constraints right now. To run Hello World, we can go ahead and generate the bit stream of our this Vivado block design. So click on run synthesis and it will first synthesize the design. So the number of jobs just mean number of cores. If you allocate more number of cores, it will synthesize faster. So it will take some time. So yeah, you can see that the synthesis has successfully completed, and now we can run the implementation part of our Vivado workflow. So yeah, run implementation. So generally there are these three major steps. You run synthesis first, you run implementation, and then you generate bit stream. And alternatively, if you just click on bit stream, it will run all the previous steps by itself. But yeah, I like to do it step by step. So I first ran synthesis and then implementation, and now we are going to be generating the bit stream. So generate bit stream and okay. So bit stream has been generated successfully. So, so what we have done so far, we have created a Vivado block design and we have generated the bit stream successfully. And now we have to export this whole hardware, including the bit stream, to our Xilinx SDK platform. We are doing this so that our SDK platform also knows about our hardware. What are the different components in the hardware, what are the different addresses. Right now we just have only one IP, which is Zynq processing system, but in most cases we have a very complicated system. We have some third-party cores, sometimes microplays, sometimes multiple block RAMs, and also sometimes customized hardware components. So all of this information needs to be exported to the SDK so that when we are writing software, we know about our hardware, we know about all the addresses in our hardware, and this is why exporting the hardware at this step is really important. So we have exported our hardware along with the bit stream, and now we will launch the SDK from Vivado. SDK is software development kit, and mostly it is used to write software which generally runs on the processing system. And the software is written mostly in C++ language. So it is reading those hardware specification which we have exported just a moment ago. So yeah, here it is. You can see that our whole hardware platform has been exported here, and there are so many different things you can find here. Think of it as the hardware platform specification. Basically, whatever we have created in Vivado, it has been exported uh, to the SDK environment. So the next step is to create a board support package. So you go into File, New, and Board Support Package. You can keep the name as it is, and here you can see that um, we have this hardware platform, which is the one which we have exported, and we keep the CPU, which is PSU Cortex A530, and you know that A5 has 4 cores, and right now we are running the bare metal application on this one single core. So we will keep it uh, so we will keep this option. So we will run the hello world application on core 0. We can keep the compiler as 64-bit, and also we can keep it as a standalone. So a board support package is basically a collection of drivers customized to the provided hardware description, and every application must be associated with a BSP. There can be multiple BSPs exist in a workspace, but for now we will just work on a single BSP, and for our application this single BSP will just work fine. So we click on finish and it will generate the BSP for our Hello World project. So you will see that this windows pops up when we click on the finish. So this is an important thing that you have to do if you are using Ultrascale 96 version 2 board. So you come in standalone. So you see that there is a standard in and a standard out, and you can see that the peripherals, the standard in peripheral and standard out peripheral, it has been configured with PSU UART0, and this is something which we have to change if you are using Ultra 96 board. So the question is, why do you have to change? So if you go into the user guide, hardware user guide of Ultra 96 board, there you will find the answer of why do you have to change this PSU UART0. MIO0 UART1 TX and MIO1 UART1 RX has been connected to UART level translator to pod connector. So this is the UART which is connected to our pod, while the UART0, if you see just down below, MIO2 UART0 RX and also MIO3 UART0 TX, this has been connected to the Wi-Fi and Bluetooth chip. So if you use UART0, you will not be able to see the debug messages on your console. You have to change this UART0 to UART1, and UART1 is connected to the pod, and this debug pod, with the help of this, you will be able to see the debug messages. So this is why we have to change that value. So we can change it to 1 and also standard out 0 to 1 and click OK. So the board support package is being generated by Xilinx SDK. It's done, and now we can create our application. Go into the file, new, an application project, type the project name, hello world, and you can see that there are a whole bunch of different options. And for example, in OS platform, we can keep it as standalone because we are just running a simple application. In hardware platform, you see that there is design_1_wrapper hardware platform 0, and this is the same platform for which we are building our application. And in processor, we are choosing the processor Core A53 Core 0, and because we are running just a simple single core hello world bare metal application, we can keep the language C. And there is one more important setting. In board support package, you don't have to click on create new, because we have just created a standalone BSP just a moment ago. So we have to use our existing standalone BSP. And the reason why it is important, because we have made some changes in our BSP. We have reconfigured our UART settings in that BSP. So this is why we should not be creating a new BSP, but we should use the existing BSP which we have just created. Click next and select hello world and click finish. This will create a hello world application, and if you go into the sources, you can see that we can see this hello world application. So yeah, let's open our putty. So at this point, I would like you to connect your Ultra 96 board. So be sure to check the boot settings. The boot settings can be configured with these buttons on your board. So if the boot setting is set in a way that it will be reading the image or the Linux image from the SD card, then you will not be able to program your board from Xilinx SDK. So you have to change your boot settings so that we can program our board from the Xilinx SDK environment. So at my end, it is connected to COM4 and the baud rate is 115200. And you can check your COM port in your device manager if you are using Windows OS. So right click on the hello world project run as, and run configuration. So we click on this Xilinx C++ system debugger. So we can reset our entire system and program the FPGA and also initialize our processing system. So we can keep these checks and apply and run. So if your boot settings are correct, you will be able to program your FPGA from the Xilinx SDK. So you can see on the putty that we can see our hello world application. So we can do another test. We can try to change the message and we will run the hello world again. So hello to the world of FPGAs. So we save it and it will build successfully. Right click, run as, run configurations. So the thing to note is that we have already programmed our FPGA. We have already initialized everything. So if we are just changing our software application, we don't have to reset our entire system. We don't have to program everything from scratch. So this will be quick the next time if you're just changing your C++ application. So we can remove these options, reset entire system and all four options. Click apply and run, and you will see that it will also just work fine. So hello to the world of FPGAs. So yeah, this is done. We have successfully run our hello world application. Thank you so much. If you have any questions, please feel free to write me in the comments and I will try my best to respond to your queries. So if you like my content so far and you learn something new from these videos, please like the video and subscribe to the channel. It actually helps the channel grow, and YouTube algorithm is gonna be recommending this video to more people and they will also be able to benefit from these educational videos. So thanks again and we will see each other in the next video. Till then, ciao ciao.